Today we are going to discuss about how to find a center of mass of a right angle triangle. An object of mass m is in the shape of a right angle triangle whose dimensions are shown in the figure. We are going to locate the coordinates of the center of mass, so we are assuming that the object has uniform mass per unit area. Now we can recollect the formula for center of mass for the x coordinate, that is 1 over total mass integral x dm. And if you want to locate the center of mass for the y coordinate, same 1 over total mass of the right angle triangle and y dm. So here we are going to solve mainly for dm. What is dm? First, in order to find the x center of mass, we shall slice the triangle into thin slices with mass dm as shown in the figure. So I am going to slice this, a small slice which has the mass of dm and it has the thickness of, this thickness is dx and the height is y, and this small slice is located from this origin at the distance of x. So here the small slice, the thickness dx and its height y, and it is x distance away from the origin, the slices. Okay, now before we do the calculation, we need to know a simple concept, theory of similar triangle. Theory of similar triangle, we can obtain this relation. Now you can see, assume this is a bigger triangle and then we make another one more triangle. I can change the color, you see. So here is one triangle and here another triangle, right? So one is big and another is small, and it is the sides are proportional. Now if here it is y and this length is b and this length, the smaller length is x and the bigger length is a, so these two sides are proportional, so y over b, and these two sides are proportional, so x over a. So here, from here, I want to find the height of the disc, the small slice. This height I want to find. This is the step 1. So from the step 1, we are using the concept of similar triangle and we are trying to figure out the length for y is equal to, you cross multiply this, so it will become bx over a. We will use this relation in the calculation for dm below. For this we are going to substitute later, so let's keep this value for y, bx over a. Right, now we are going to do the second step, step 2. In the step 2, we have some formula to find out, that is mass per unit area, rho. So the rho density can be assumed as mass per volume, mass per area, mass per length, because in the given area the mass, amount of particles located, will not be changed as it is in the volume. So amount of particle is constant for the given sample. That if the density of the sample is same, the mass is same in a given area or given volume or given length. So it's not a matter if it is mass by area, it's not a problem. It's same like mass by volume, mass by length. Okay, so from this what are we going to find out? We're applying the values, the formulas here. The mass, you can keep mass as it is, because the mass of the right angle, total mass of right angle triangle, and this area of the right angle triangle. So the area of right angle triangle is half AB. If you simplify, it will be AB divided by 2, and if you take the reciprocal, it will be like this, 2m over AB. So now we found the density equation, that is 2 mass divided by the multiplication of two sides of the right angle triangle. So this is the step 2. Here we are going to do the step 3. In the step 3 we are writing the formula for center of mass for the x coordinate, and here the dm value we are going to calculate. That is step 3. dm is equal to density, the mass formula is density multiplied by area. Here, as it is a small mass, a sliced mass from the given shape, so the area also a small area of the sliced mass. And here the density, if it is a big or small, will not change. The density is always constant. And the area of the sliced shape is like a rectangle, so it has the length and area, sorry, length and breadth. So the density is same rho. The length is here dx, and the breadth is here y, or you can change length and breadth, no problem, dx y or y dx, right? Here is the height or length, breadth you can take, or height, everything. We need two sides for the area. Okay, fine. Now we have the value of y. We can put here rho multiply by dx multiply by bx over a. Here we have already we found from the similar triangle. Now we can use it, bx over a. So always we keep this dx last. So rho b by a is a constant, so we need x and y variables, and here the dx is written. So this is the step 3, that we are finding the mass, a small mass, the sliced a small portion from the given right angle triangle, right? So I am going to substitute this value here. So let's continue this. So 1 divided by mass, and now the limit, we are going to apply the limit as we are finding for the x-axis. So the initial point is 0, the final point is a, the total length is a, 0 to a. This is the limit, 0 to a will be the limit here. So 0 to a, and x, you write x as it is. In the place of dm, we are going to substitute these values. So density rho b by a x dx. Okay, now we can take the constants out. You can take, these are all the constants, you can take this outside. So 1 over m rho b by a, and integration 0 to a x dx, right? Okay, now what we have to do, we have to substitute this value, the rho value. Already we have 1 over mass, the rho value is here 2m over AB, 2m over AB, and multiply by this B over A, and integration 0 to A. Here x times x square, I forgot to write this, x square dx. Okay, now we can simplify this. So here the mass is cancelled, and b is cancelled. So what we have, the rest, 2 divided by a square, 2 divided by a square. Now I want to take the solve the integration, the x square dx. Integration for x square dx will be x 3, x power 3, x cube divided by 3. This is the answer for x square dx integration, x cube divided by 3. And we substitute the limit here 0 to a. So the first we apply for the upper limit, then lower limit. Now I am not going to apply for the lower limit because the value will be 0. So let's apply for the upper limit. 2 over a square multiply by, if you apply this a into x, it becomes a cube over 3. Now you can simplify again. This a square, here 3 a's are there, 2 a's are cut, then remaining 2a over 3. So this is the center of mass for the x coordinate, 2a over 3. So in similar way we are going to find for y coordinate. This time this vertical portion will be changed as a horizontal portion. Here we will be slicing into horizontal and do the same process. We will be finding the same thing here. The density will be the same, right? Here will be y dm. So only the dm value we will be finding. So let's see how it goes. Here we are going to find the center of mass for the y coordinate, and here we have taken this slice horizontal for the x-axis, and the thickness is here dy, because the thickness is in the parallel to the y-axis, so we write here dy for the thickness. Before in the x center of mass we have written dx, right? But here dy because the thickness is parallel to y-axis. Okay, now this particular slice is away from x-axis. The length or the height we can consider as y, and here we can draw the same triangle, similar triangle, and from the origin the slice is away from x, and the total length is a, the total length of the base is a. So up to here this distance is x, so this distance will be the total length minus the x, this x, total length a minus x. So this is the breadth of the taken small slice, and the mass of the small slice as usual it is dm, right? So what is the formula of center of mass for the y coordinate? 1 over capital M total mass and integration y dm. So we are going to first find dm. Let's see here, dm is equal to density multiplied by unit area. So this area is a small area, so we can write delta A because it's a small piece. So density will not be changed, it is same density of the right angle triangle, and delta A length into breadth. So rho is rho, density will not change. The length here A minus x, this length here to here, the length a minus x multiplied by b. B is the breadth, breadth is here, this thickness, right? So dy. So we can keep this one for the later substitution in the formula. And we know the density, already we found it, that is 2m over AB, right? Okay. And then another, the similar triangle also we know, that is same as it is before we found from the similar triangle, y over b is equal to x over a. The y is the smaller side and b is the bigger side, the height, and here x, this base, smaller triangle base, and a is the bigger triangle base. Okay, from here now this time we are going to find for x value. Before we found for y, here we find for x. So x is equal to how much? You cross multiply this, ay over b. So this is the another equation. Okay, now we can substitute all the values in this main equation. 1 over mass, and this integration here now 0 to b, because the length, the height is here 0 and here b, the total limit is 0 to b. Now we are finding the center of mass, the location of center of mass from the limit 0 to b. Okay, now in the place of y, same, no need to change y. Now we have to substitute this dm value. It is here, write the same as it is, rho a minus x dy. Now we have to substitute x value, we already found here. So y rho a minus x ay over b, just we substitute this value, x value here, and dy. So no more change. So here next step, you can take the density rho outside and write here 0 to a, other values as it is, a minus ay over b and dy. Now next step, we can multiply the values, this one, y a is ay and dy is there outside, it is common for these two terms, so dy minus multiply this to here, ay square divided by b, and dy is common for both terms, so write dy. Okay, now we are going to take the integration, and this integration is for y dy. So here this a is constant, the constant will not change, we can write as it is, and this y power 1, y power 1, so it becomes 1 plus 1 2 divided by 1 plus 1 2, y square divided by 2, this dy will be disappeared in integration. That is the rule of integration. If you don't know, you can just recollect integration, then it will be easier for you. And here again this constant, write the constant, this y square will be y cube, 2 plus 1 is 3 divided by 2 plus 1 3, already b is there, so you can include that b here, and dy will be disappeared, and you can close right here the limit 0 to b. Okay, now 1 over m, the row is here, I forgot to write here, the row is here. Now I am going to substitute the row value, that is 2m over ab in the place of row. Here this row is here, and in the bracket I apply the limit value for y, right? In the place of y, just you replace with this b, so it becomes ab square. Now the limit is applied, divided by 2 minus ay cube b cube, ab cube divided by 3b. Now if you apply the lower limit, the complete term will be 0, right? So I'm not going to apply this. Now you can simplify here. This mass cancel. So outside you will be having this 2ab. And here if you simplify, before simplification you can cancel this b here, b square, right? So now you see here ab square, ab square. So numerators are same. Now you can cross multiply this. 3ab square is minus, here is minus, you multiply this 2 with this terms, 2ab square divided by, multiply this 2 times 3, 6. This is a mathematic rule. So now again I simplify, 2 divided by ab. 3ab square minus 2ab square will be 1ab square. So ab square divided by 6. Now again you can simplify. So a cancel and b, here 1b is cancelled, and this 2 you can cancel this by 3. So on the numerator you have only b. So right here b, and the numerator you have only 3. So denominator you have only 3. So b over 3. So center of mass for the y coordinate will be b over 3. Okay, so we found the location of center of mass for x and y. Thank you very much.